3D printing is the new hot technology for dental, and you just want the basics of how 3D printing works and all the jargon around it? Hi, I'm Brent Garvin, and in this Be Informed e-learning video, I will go over some of the basics of 3D printing so you have a better understanding. So 3D printing is truly having an impact on chairside fabrication in dental and has many applications. The industry is looking to quickly produce things such as models, surgical guides, occlusal guards, night guards, aligners, retainers, sleep appliances, dentures, and even temporaries. The demand for the same-day turnaround for these types of products and more is being driven by both the dental professional and their patients. So let's first look at the different printing technologies. In dental, we basically have three different types of technology as of today that you need to know. There's DLP, SLA, and LCD. DLP utilizes a projection bulb as its source to cure the object. If you remember the initial days of large, flat screen style TVs, DLP was a very popular style, and this old technology was repurposed for 3D printing devices. A bulb that needs to be replaced is used to make things happen with a DLP style printer. Its advantage, some will say, is it can produce faster print times than an SLA style printer. Speaking of SLA, it was designed to provide high quality, accurate prints utilizing lasers to create the object. It does a fabulous job, but has limitations when it comes to multiple prints because the laser travels around the object to create it, which can limit the number of objects and adds time to the print because the light is a single point and has to travel around to print. And then it also needs to separate each layer in order to move up the Z-axis. And then there's LCD, like the Planmeca Creo C5. It utilizes long-lasting LED as its light source, and the LCD has two layers of polarized glass, which either blocks or allows the LED light to pass through to create the object. They're extremely fast, accurate, and in the world of 3D printing has no optical distortion, which is a cool term you can use. When it comes to resolutions of 3D printers, you will hear terms like X, Y, and Z resolutions, and they are usually measured in micrometers, and the symbol looks like this. So think of your X and Y as being the resolution from left to right or front to back, and the important Z-axis is your resolution of your actual layer thickness as the object's height is being built. So the smaller the resolution or micrometers, the thinner the slice, the higher the resolution. So now let's cover some of the parts and components of a 3D printer. A dental 3D printer has a build platform. Think of this as a plate that the object is printed on. If you have a cell phone, you can take it out and think of that as your build platform. What you can physically set on that cell phone is basically what you could print. How high the build platform can move up or the light source can move away from the fixed build platform location will determine how high of an object you can print in your printer. The other main component of a 3D printer is the basin. This is where the resin material used to create the print is located during the print job. For printers that have a build platform that is coming down into the basin to get the resin, think of it like the Terminator movie where he was growing out of the liquid below. So the basin is either filled with the resin material by pouring it in by hand, or the printer will have a print cartridge like your computer printer does to keep things clean and easy. So you will hear the term posts or supports when it comes to 3D printing. They're pretty simple. To take advantage of the build platform size, you will see objects stacked more vertically or angled. The designer will attach what are called posts or supports to give the build platform something to attach the object to for several reasons. One of the main reasons is if you printed something that had an extension, you would have to have something to support that. Otherwise, you would have a secondary object off to the side that wouldn't be attached to your main object. I like to use the analogy of a water tower. If it didn't have supports, how would it be suspended? Now think of that in the 3D printing world. We would need those supports in order to print the water tower as an object. So when it comes to software and design and the final modifications of the object you are going to print, you will of course need a few things. First, a design software to obviously design the object, and then a software that is used to make final modifications. Many use a free software that you hear about called MESHMIXER. This is where they take their designed object to and make any modifications to it. A good example is taking a guide design software like Planmeca's Guide Design and creating a guide without an actual space holder for the drill or drill sleeve, and then they take it into MESHMIXER and modify it to make an occlusal guard. Otherwise, you look for softwares that actually can do both design and modifications all in one location. The other word you will hear when it comes to 3D printers is nesting software. Think of this as that window that pops up on your computer when you hit print on the document you want to print. It's the software that stages and then hands off the print job to the printer. That's where you will move the object around virtually to take advantage of the build platform size for multiple objects, as well as place your supports or posts required for what or the way you are printing the object. The last thing we'll cover is post-processing. Once you take the object out, you have a couple more steps. You will typically clean the object by submerging it into a small ultrasonic and then dry the object once it's removed, and then move it into a UV light curing station to final cure the object, which will take a few minutes. Once completed, you can trim or snap off your supports and make any final adjustments to your object to shape and smooth to a final finish. So hopefully you learned something new and know a little bit more about dental 3D printers if you are new to it. Like I always say, it's a noisy world out there with lots of information that can be either accurate or not so much. So just be informed. So if you enjoyed this e-learning video, please take the time to hit the like button and also subscribe to my Facebook channel to learn of the new videos as they become available. And also, if you have any requests for future topics that you think would be valuable, please let me know in the comment section below. Thanks for watching.